Today, I'm ranking the most popular local AI use cases for you based on real engineering experience. For each category, I'll recommend the one model or tool that I would start with so you can skip hours of research and just get going. Personally, I've spent hundreds of hours testing with my RTX 5090, but a lot of cases work on weaker hardware too. So, with that being said, let's get right into it. First up, we're going to start with local code autocomplete, and this is straight up S tier. Code autocomplete is one of the first ways that we were using AI for automated coding with something like GitHub Copilot. When you type code, the model finishes your line or even fills in a function body before you can think about it. And while agentic coding seems to be taking over the world, code autocomplete is still extremely useful. And the great part is that it absolutely works great with local models. One model you could use is something like Qwen 2.5 Coder because it's a small 7 billion parameter model, which can run at sub 100 millisecond latency even sometimes on GPUs with just a couple gigabytes of VRAM. Now, you're gonna sometimes even get results that are faster than network-based autocompletes because there's no round trip. You're just, executing this with local models. And this gives you a similar experience as the code autocomplete models that were state of the art a couple of years ago. You can pair your local model with something like Continue Dev and use Olama for the inference. And then you've got a self-hosted Copilot replacement, at the very least, the autocomplete features of it, that costs nothing after hardware. While this doesn't beat the newest agentic features that you get with things like Claude Code, Copilot, Codex, it's a great start, and this actually works well locally. Local can beat cloud models here on the metric that matters most when it comes to autocomplete, which is response speed, and you can fully customize it yourself as well. We're going to be talking about other coding use cases later, but first, let's move to something different, photo enhancement. This is something that I would comfortably place in A tier. Photo enhancement covers things like upscaling, face restoration, background removal, noise reduction, colorization, anything basically where you take an existing image and you make it better without generating new content. I'll focus on upscaling for now, as this is an example that is very common, but the whole category is strong locally. A tool that you can get started with easily is something like Upscaly. It's a free open source desktop app that uses real ESR GAN models. You don't have to screw around too much with Python, you don't need the command line yet, no custom GPU configuration. Just to see what's possible, you drag a photo in and you will get a 4x or even 8x upscaled version out of it. From there, because you can see what's possible, you can go ahead and try and play around with the models yourself and create a custom workflow that works for whatever you need to do. It's great to be able to enhance your photos without having to rely on only a cloud-based version of Photoshop. And any dedicated GPU with something like 4 gigabytes of VRAM can handle this use case in just seconds. Another great use case is home automation. Home automation covers many different tasks, but the whole category can definitely be A tier. With home automation, you can have use cases like having your security cameras detect a person in your driveway and your phone getting a notification with a snapshot, which will all be processed on a box in your closet. And the great part about this is that you will not have a cloud subscription anymore. And maybe more importantly, your security footage leaving your network to be stored on maybe some random Chinese cloud that you don't know about. Object detection is the headline feature here, but local home automation can also cover voice control, presence sensing, and even energy monitoring. In any case, the stack that you can start with is Frigate NVR plus Home Assistant. This is probably the most mature local AI ecosystem that exists right now, especially for beginners. With this, you can have use cases like person detection, vehicle detection, pets, packages, license plates, and even some basic facial recognition as part of some of the latest Frigate versions. And all of this will be processed entirely on your hardware. Home Assistant has over 2 million active installations and Frigate has over 30,000 stars on GitHub, so you're not going to be alone. It's not just a hobby project, it will be a full ecosystem that you can plug into. The only thing keeping this from S tier is the setup complexity. You often will have to configure Docker, camera streams, detection zones, and even if it's running, it might break in a couple of weeks because things update fast in the home automation space. Now, you might be already thinking, this is a nice tier list so far, but how do I get started? Well, I put together a collection of my own open source projects for many of the local AI use cases we're covering today. The link is in the description and you should definitely check it out. A whole different use case is video generation. And this one is a little bit disappointing. I'm going to put it in the C tier because the idea behind video generation is that you can type a prompt and get a full video clip out. Something you can use for product demos, social media content, or just content visualization. This is the category everyone wants to work locally because cloud video generation is expensive and rate limited. Problem is though that it's still very expensive to generate locally in terms of the time that it takes, and the quality is just not great. One model you can try is WAN 2.1 from Alibaba, which can beat Sora on several benchmarks, which was, a state-of-the-art model a while back. The issue is, though, that even on my 1590, I can't really use the full 14 billion model. I already have to kind of go down to the smaller 5 billion parameter one, and the quality is just a lot less. In addition, because it takes a long time to generate video, it is also a lot more time expensive to generate many variants to figure out how you can generate a video clip that actually looks good. Compared to image generation, which we'll get to later, you don't just generate one frame. To get a good video, you need to generate many different frames, and that just takes a long time. Locally, this might be usable for some experimental social media clips and concept work, but real professional production is still cloud territory, and that's why this is going in C tier. Speaking of something that's related, image generation. Now this works much better. I would put image generation in the S tier. With image generation, you describe an image and the model can create it. You can use it for thumbnails, marketing assets, product mockups, and concept art. This can also include in-painting, out-painting, basically editing the existing image, and even generating a new image variant based on an image that you're passing to it. Now, I'll focus on text-to-image generation because that's where most people start. The model you can use here is Flux2Dev, which you can run through Comfy UI. On something like my 5090, this is a very comfortable use case, and it's very easy for me to generate an image in just a couple of seconds. Unlike video generation, this means that you can generate hundreds of variants in, a short amount of time, which increases the chances that you actually get an image that you're happy with. And in fact, Flux is a really good model because in some blind tests, it achieved a 71% win rate over some of the older Midjourney versions for editorial photorealism. So the models are really getting much better. And with image generation, I've also found that there's a really great community where folks have fine-tuned a lot of models for custom characters and styles. And there's even a lot of image generation models that have less content filters than the one in the cloud. It's good that cloud has content filters, especially for copyright, but sometimes they go a little bit too far and they become a bit unusable, to be honest. And actually training a custom LoRa model or actually fine-tuning one only takes 15 to 20 images, and you can do that on consumer hardware as well. Now, one thing that I've learned from using AI image generation for my own content is that iterative editing is where it gets a bit tricky. Image properties like gradients and complex textures make it very difficult for those local models to edit images without losing quality. Personally, this is still where I use the latest Nano Banana model or just use Photoshop to just make sure that I can use some of the cloud features. So even though it's S tier, there are some use cases where it's going to fall behind a little bit, but it is really getting better every single month. A completely different but fun use case is voice agents. Now, this one is something that I'm going to place in C tier because of the wide variety of use cases which can work in a variety of ways. Basically, the idea behind voice agents is that you can talk to your computer and it will talk back, like a local Alexa or customer support bot that runs on your hardware. But ideally, it should also be able to, do actions for you. For example, you can use it to do hands-free home automation. The best open source option right now would be something like PipeCat, which can chain together a speech-to-text model, an LLM, and then a text-to-speech model into one single pipeline. And that will allow you to get something like sub 800 millisecond voice-to-voice latency on some standard hardware on something like macOS. The problem is that the model size constraint means that the AI's responses locally are noticeably dumber than you can get from the best local models that you interact with over chat, and of course, the best cloud models. In fact, this is even an issue with cloud voice agents. They can achieve 200 to 500 millisecond latency, but their intelligence is more around GPT-4o level and not the latest models that are out there. And of course, this intelligence gap is much higher for local voice agents. That being said, if you just have a singular command that you want to run, voice agents can work pretty well. The main issue where they lack quality is in longer conversations, because with local models, you're just much more constrained on your context window, which means that as you have a long conversation with a voice agent, it will simply go off track. And you don't have that issue if your voice agent is just there to process one command and execute it. So that would be the recommended use case, I would say. Now, one component of voice agents is a text-to-speech model, and you can use text-to-speech on its own. And on its own, this is definitely A tier. With text-to-speech, you feed text in and you get natural sounding audio out. You can use this for audiobook narration, voice-over for video, accessibility features in your app, or even trying to clone your own voice for content, which I've tried, but that one is a bit ambitious. It doesn't work very well. Now, this category also covers music generation and sound effects because it's not really my specialty. In general, though, voice synthesis is where local models have made the biggest gains. Now, text to speech has had the most dramatic transformation, in my opinion, of any local AI category in the past 18 months, because I would say that it's almost a solved problem at this point, especially for the English language. The model that I would start with is Chatterbox from Resemble AI because it beats ElevenLabs in a couple of blind tests with over 60% listener preference rates. And the base model might be English only, but you can even go to Chatterbox Multilingual, which covers 23 plus languages. And so the gap versus a cloud offering like ElevenLabs has closed for a lot of use cases. And in some cases, the gap is gone entirely. There are some gotchas. A lot of models will hallucinate or really degrade in quality past about 1,000 characters, but there's a lot of ways to solve that. You can split up your text in multiple batches and just process them one by one. Now, if you're finding this tier list useful, make sure to hit subscribe because over 90% of you are missing out on the latest AI engineering news that's based on reality and not hype. So make sure to join the club. Next, we're going to be talking about speech to text, which is another component of voice agents that you can extract on its own, and it's another solved problem, in my opinion. Speech to text is absolutely S tier. You record audio or you pass an audio file and you can get a text transcript back for meeting notes, podcast transcription, subtitle generation, or just turning your voice memos into searchable text. I use this constantly myself for processing my own YouTube video content. And for English, it works very well. A model you can use is Faster Whisper with large V3 Turbo, which gives you over 4 times speed over the original Whisper model. And the real workflow that I use is a two-stage pipeline. I use Whisper to get a fast, accurate raw transcription, and then I use a local LLM to clean up filler words and extract the core meaning. And this way I can store the notes into something like my Obsidian Vault to reference later. The transcription itself is almost instant, but the LLM cleanup step does add some time. The thing is though, I can just run it in the background, so that's not an issue at all for me. The gap of cloud models is mainly with speaker diarization, which means that you can split up some audio context into the different speakers. So let's say you have a meeting with 10 people, you want to be able to know who's speaking which sentences, right? Cloud models are a little bit better at doing that, but I fully believe that local models will catch up very quickly. The core use case of transcribing audio just works very well nowadays with local models. Next, we're going to be talking about OCR, Optical Character Recognition, which I'm going to comfortably place as our first B tier. OCR covers table extraction, formula recognition, and just converting scanned documents into structured data, which is useful for so many use cases. One tool to start with is Surya, or you can use a DeepSeek OCR model that has been released recently. Now, a lot of the use cases are a little bit more on the boring side, like being able to transfer and process invoices, but it does work pretty well. Next, we're going to be talking about Agentic Coding, which is much more interesting than just doing code autocomplete and seems to be hyped up more and more for local models. Now, the one disappointing thing about Agentic Coding is that it doesn't work that well unless you have very good hardware. A lot of YouTube videos, they show Agentic Coding and then they show how it can generate Python code, and that's good and all, but with Agentic Coding, you really want a model to be competent enough to read your entire code base, write code, run tests, and iterate until your feature works, the feature that you asked for with text. The issue is, though, that absolutely most hardware is too incompetent for Agentic Coding. Now, I've created many videos on my channel covering how performant Agentic Coding is on my 5090, and it's definitely getting closer, but it is nowhere near as useful as using code autocomplete, nor something like an AI chat, because eventually local AI agents choke on larger projects. That being said, this is something that improves every single month, so definitely check out the videos that I have in my channel, which I'll put in the link in the description below, to get the most out of your local setup, because it's very difficult to set up properly, and you really need a bit of an expert guide to do this right. With Agentic Coding, you might be able to match something like GPT-4o locally, but Claude Opus 4.6 and similar models have really upped the game here, and there is just a huge gap between what you can do locally versus with the state-of-the-art cloud models. Even if your local model is intelligent enough, the problem is that it will get slow as the context window fills up. And unlike with these other use cases where you can clear out the context window after you improve small bits of the task, with Agentic Coding, you cannot clear the context window with every step. you need the coding model to have a good idea of how your code base works. So in the end, these models are going to work very slowly on your local hardware, especially compared to cloud models, unless you have a very beefy PC. Most people promoting local models with agentic coding are not using it for serious projects, and if you don't believe me, check out some of my masterclasses on this channel to learn the truth. If you do want to get started with agentic coding, I recommend some of the latest Quen models, but again, I covered that extensively in the videos on my channel already, so go check those out. As models get stronger, I expect it to move into A or S tier, especially as local models will catch up as well. You know what isn't A tier yet though? AI chats, a traditional use case. With AI chats, you can ask questions, brainstorm ideas, summarize documents, draft emails, the same stuff you would use something like ChatGPT for, but it can run entirely on your machine with no data leaving your network. I would recommend new models like something like Qwen 330B through LM Studio, and this is a pretty optimized model that can run pretty fast, but honestly, there's many choices for AI chat models. You can use a newer Mistral model, or even check out the older but still competent open source OpenAI model that's out there. In any case, locally, you can really mimic what GPT-4o was able to do a year plus ago, and now fully locally. You can use it for so many different purposes that it's just a great use case altogether, and a very beginner-friendly one because everyone understands the concept of an AI chat, right? The great part too is that you have many choices for the right user interface here. You can use something like LM Studio, which is a desktop app that already has a chat UI, or even create your own web app and customize it to your liking. There are so many open source repos, and again, check out the link in the description if you want to make a good start on that, because I've got many templates for you to customize. A specific subset of AI chats is RAG, Retrieval Augmented Generation, which is a very fancy word that some of you probably already know about, which is the fact that you can point an AI at your own files, company documents, research papers, or notes, and it will answer questions based on that content. It's pretty similar to AI chats, but the thing is that generally it's a bit more expensive and complex to set up. You might have to put your documents into a vector database, and you have to make sure that those documents are retrieved properly to make sure that the AI chats can answer questions about them. But if you do it right, well, this can work very well for your own use cases and to make sure that these local models are up to date with the latest knowledge in your use case, which is not in the training data of the model, especially because some of these open source models have been trained half a year or a year ago. So RAG is a very important paradigm, and I'm putting it in B tier because of the technical complexity to set it up, but it is kind of a requirement for a lot of real AI chat use cases. So it's definitely something you want to learn to set up yourself. One tool you can start with is something like OpenWebUI, which gives you a full RAG pipeline out of the box with a clean interface. And the nice part about this is that because it's all running locally, data privacy is the consistent top reason enterprises will use these kinds of self-hosted LLMs. So if you learn these skills, you can definitely get an AI engineering job with that as well. So we have talked about some AI use cases now, like a chat, a RAG chat, we have agentic coding, code autocomplete, but what about the ability to create any AI agent of your dream, where I'm defining an agent as a system that can autonomously make decisions, execute actual actions for you, and be able to solve a problem in many different ways. Well, the thing is, a true AI agent is very difficult to run locally. I'm going to put it in C tier, but I wanted to make sure I explain this to you, because you've probably seen many videos here on YouTube talking about AI agents. The problem is, though, that most of those videos are not real agents. They're more deterministic workflows in something like Any10 with a small LLM component in the middle that might make one or two decisions. But a true AI agent that can run like Claude Code simply requires a very good language model, or else it will get confused about all the tools it has access to, it will not be able to run autonomously without you pushing it into the right direction, and you will just find that there are many issues with it in general. That being said, I'm not saying that AI agents are incapable to work locally, it just depends on your use case. And most people that I've talked to who want to build their first AI agent are a little bit too ambitious. They might want to build a research agent that works better than something you can use with OpenAI GPT Pro. But to be quite honest, it's very difficult to build a better AI agent than using a platform that you can access over the cloud, again, something like Claude Code. Because even with Claude Code, you can point it to a local model, but it just won't perform in the same autonomous way. That being said, AI agents in particular change all the time, and I expect that as models get better, this will move up to the B tier and the A tier eventually. But even then, AI agents simply won't run on weak hardware because of literal mathematical constraints that I've covered in other videos on my channel. So depending on your use case, this is just not going to work very well. But if you think that that's not true and you have had good experiences creating local AI agents, I would love to hear it from you in the comments down below. But please tell me what use case you have, because most people trying to run local AI agents aren't really running true agents. They're just running regular workflows with LLMs sprinkled somewhere in between. But how about a more simple AI assistant that you can run locally, like, OpenClaw? An always-on personal AI that manages your calendar, triages your emails, summarizes your day, and handles whatever you throw at it for personal use cases. The local version of Siri or Google Assistant, but running private and 24/7 on your own hardware. So tools like OpenClaw aim to be exactly this and sound great on paper. The issue is, though, that setting them up properly in a secure way that makes sure that you actually keep your account secure is pretty difficult. It does require a little bit of security knowledge. Because of that complexity, I would right now put AI assistants into the B tier, because it can work quite well if you are very aware of the security problems with something like OpenClaw. Now, personally, I would still use OpenClaw with a state-of-the-art cloud model because they're much better protected against things like jailbreaks. But there may be one exception where I would use local models, which is for well-defined cron jobs, which are things that run on a schedule, like every 8 hours. This might be something where you are summarizing your feed into a daily digest or just classifying your incoming emails. For something like this, a local 14 billion model works just fine. And yes, you can use a local model with that. So far, we have a lot of use cases and they all are pretty competent, right? Even the ones in C tier, they're very usable and they're getting better every single day. But then what is the D tier for? Well, to be honest, that's for vibe coding. Vibe coding with local models just doesn't work. The idea with vibe coding is that you just describe an app in plain English and the AI will build the whole thing, and you never read the code, you just judge whether the result works. And this is different from agentic coding because you are not explicitly reviewing or steering anything. Now, honestly, this workflow needs a frontier model to cover for the fact that you're not reviewing at all what it writes. A small language model can code quite well with the right guidance in a couple of files, and for models under 14 billion parameters, you cannot even use tool calling properly, which is a requirement for proper agentic coding, let alone vibe coding where you're not guiding the model at all. Vibe coding with cloud models already has serious problems. Researchers found security vulnerabilities in 1 out of 10 lovable generated apps, for example. But with weaker local models, those problems multiply. So let's recap this tier list a little bit. The 3 S tier use cases genuinely match or sometimes even beat cloud models: code autocomplete, image generation, and speech to text. The pattern here is that some of the more boring use cases consistently outperform the hyped ones for local models. However, as models get better, some of the more complex workflows like AI agents as well as voice agents will just get better over time, and hopefully everything will be in the B tier or above in a couple of years from now. And if you want to get started with local AI projects, you should check out the link in the description below and get started today.